Hello students, a very warm welcome to BYJU'S Classes. This is Nidhi and today we are going to discuss 26th February second shift mathematics paper which was held this year for JEE Mains conducted by NTA. The next question is from Matrices and it was not difficult but yeah, it is a bit lengthy question. The question says that they have given us a matrix A which is satisfying the equation a raised to 20 plus alpha a raised to 19 plus beta a that is equal to another matrix given to us as a diagonal matrix having elements as 1, 4 and -1 in the diagonal. Okay, rest of them are definitely 0. What is the value of beta minus alpha is what they have asked. So here what you have to do is definitely I have to obtain a raised to 20 and a raised to 19 to get alpha and beta. That is one thing. And for that, I have to obviously find a square or a cube till maybe a raised to 4 to observe what the pattern is. So that is the part which made the question a bit lengthier. So to find a square, we know you have to multiply a into a, further a cube and a raised to 4. So let's see what the pattern is coming out as. Okay, so the question is this. First, let's find a square. So a square is nothing but a into a. That is going to become 1, 0, 0, 0, 2, 0, 3, 0, minus 1 multiplied by again 1, 0, 0, 0, 2, 0, 3, 0, minus 1. So when I multiply this, it's going to become 1 multiplied by the first row actually multiplies by the first column. It is going to give me 1. Then my first row gets multiplied by the second column. It's going to give me 0. When it's multiplied by the third column, again is going to give me 0. This is how basically you multiply, right? Okay, then I have my second row. Again, by doing the same thing, row is multiplied by first, third and second column. So it's going to give me 0. Then 4. Then again 0. And then I have my third row. When I multiply in the same way, it's going to give me 3 minus 3. Well, that is 0. Then I have again a 0 and then I have 1. Okay, so that means I have my a square with me, right? This is my a square. Now, when I have to find a cube, I'll multiply my a square into a. So it is 1, 0, 0. 0, 4, 0, 0, 0, 1 multiplied by a which is 1, 0, 0, 0, 2, 0, 3, 0, minus 1. Again, I hope you can multiply the matrices in the same way which we have done. So it's giving me 1 in the first one. Then I have 0 and 0, right? Similarly, my second row is going to give me the first element is 0. The next one is 4 into 2, 8. Again, a big 0. Then I have 3 with me. Then it will become 0 and then it will become minus 1. Okay, so that means my a cube pattern has again changed. It is having an element like 3, 0, minus 1 which is same as my element in a. The last row is same but the middle element here is 8. So what I have seen till now is that my a square is a diagonal matrix. I have 4 over here, which is nothing but 2 square. My a cube has the last row same as that of a and my middle element here is 2 cube, that is 8. Okay, so let's find a raised to 4 also and then I guess we can tell what the pattern is coming out as, right? So my a raised to 4 when I multiply a cube that is 1, 0, 0, 0, 8, 0, 3, 0, minus 1 multiplied by a again that is 1, 0, 0, 0, 2, 0, 3, 0, minus 1. Either you can go like that or you can multiply a square into a square. This when you solve, you'll get the matrix like this. This will be the matrix. So that means my a raised to 4 again is a diagonal matrix with the middle element as 2 raised to 4. So now I hope the pattern is clear to us, right? My a cube will have the same kind of terms except the middle term which is 2 raised to 1. Then in a square it became 2 square. Then in a cube it's 2 raised to 3. A4 it's 2 raised to 4 and so on. While the even ones that are a square and a raised to 4 are all diagonal matrices with these elements as 1 in every case. So that means when I write my a raised to 19, which is odd, I'm going to get a similar pattern as that of a and a cube, right? So it will be 1, 0, 0, 0. Now the middle element here will be nothing but 2 raised to 19. By again observing the pattern, this is 0, the last one has to be 3, 0 and minus 1. Similarly, when I go to my even part, I'll have the same 1, 0, 0, then I'll have 0. This is going to be 2 raised to 20, 0, 0, 0, 1, following the pattern of a square and a raised to 4. So when we repeat this, this is the final thing we have got. Understood? Perfect. Now we have to just substitute a raised to 20, a raised to 19 and a in this relation and get the value of beta and alpha, thus getting the final answer of beta minus alpha. Clear? Okay. So when we substitute, let's say in the in the left hand side, it's going to give me a raised to 20, which is 1, 0, 0, 0, 2 raised to 20, 0, 0, 0, 1. Then I have alpha times a raised to 19. So when I multiply alpha with matrix, all the elements will get multiplied by alpha. So my alpha a raised to 19 is going to become alpha 0, 0, 0, 2 raised to 19 multiplied by alpha. And then I have 0. Then it is 3 alpha 0 minus alpha. And then I have plus a plus beta a. So again, beta is going to get multiplied by a. So it's going to become beta 0, 0, 0, 2 beta 0, 3 beta 0 minus beta. Right? Now, if I want to combine the elements, it's going to become somewhat like this. I'll have 1 plus alpha plus beta. Rest of the elements will become 0. Then here it is a 0. Here it will be 2 beta plus 2 raised to 19 alpha plus 2 raised to 20. Again a 0. Then here it is 3 times of alpha plus beta, 0. And 1 minus alpha plus beta in the bracket. And this was equal to our RHS, which was given to us in the question. So when we compare these two matrices, I have A31, that is this 0, is equal to 3 times of alpha plus beta. So that is going to give me that my alpha plus beta value is coming out as 0. First relation is this. And similarly, if I compare my A22, the middle element, that is 2 multiplied by beta plus 2 raised to 18 into alpha plus 2 raised to 19 is equal to 4. So this 2 got cancelled out. And in place of alpha, I'm writing, or let's say in place of beta, I'm writing minus alpha and substituting over here. So it's going to give me 2 raised to 18 into alpha minus alpha plus 2 raised to 19 is equal to 2. Further, I can say that when I take 2 raised to 18 common, it's alpha plus 2 is equal to alpha plus 2. So that means my alpha plus 2 value has to be 0, right? So if this is the case, that means my alpha value is minus 2, beta value will come out as 2. And what have they asked us finally? They have asked us the value of beta minus alpha. So I can clearly say that my beta minus alpha will become 2 minus minus 2, that is 4. This is going to be the final answer for this question. Clear? So this is the solution. You have to observe the pattern and keep the values. That is going to take time. So if you have attempted rest of the questions and still time is left and you want to attempt the question, then only you should go for this question. Clear? Perfect. So the answer is 4. Well, the next question is from sequence and series. The question is saying if the arithmetic mean and geometric mean of pth and qth term of the sequence minus 16, 8, minus 4, 2 and so on. What the sequence is, guys? Well, this is a GP. That's correct. This is a GP with common ratio R is equal to minus 1 by 2. Right? So that means I have to find pth term and qth term of this GP. And Then I have arithmetic mean and geometric mean. Let's say these are A and G. So these A and G are roots of the equation 4x square minus 9x plus 5 equal to 0. If that is the case, what is the value of P plus Q? Okay, so we have to find what is the value of P plus Q, right? So first of all, to get P plus Q, I have to solve for two things. First, I have to find the arithmetic mean and geometric mean and equate that to roots of this equation. Clear? Perfect. So first of all, let's quickly find the arithmetic mean and geometric mean. So we have already seen that this is a GP whose first term is minus 16 and common ratio is minus 1 by 2. What is the pth term? First of all, pth term is, you know the formula, it's a into r raised to p minus 1. So it's going to become minus 16 multiplied by r. That is minus half raised to p minus 1. So my pth term is a, that is minus 16 multiplied by minus half raised to p minus 1. Clear? Similarly, quickly writing down the qth term, that is again minus 16 multiplied by minus half raised to q minus 1. So the arithmetic mean will be obviously average of these two, which is minus 16 multiplied by minus half raised to p minus 1 plus minus half raised to q minus 1 whole divided by 2, right? And similarly, the geometric mean, you know the formula is root over AB. So when I multiply pth term and qth term, it's going to become 16 square multiplied by minus half plus p plus q minus 2 whole raised to 1 by 2. This is the geometric mean. And what they have said that arithmetic mean and geometric mean are roots of this quadratic equation. So let's quickly factorize and find the roots for this equation. So this equation is 4x square minus 9x is 4x minus 5x plus 5 is equal to 0. When you actually find out the roots will come out as x is equal to 1 and 5 by 4. Now comes the question, which of these two will be the arithmetic mean and which will become the geometric mean? Well, for that we have to again remember one thing, that arithmetic mean is always greater than or equal to geometric mean, right? So if this is the case, definitely 5 by 4 will become the arithmetic mean and 1 will become the geometric mean. So what we are going to do? We are equating this geometric mean to 1 and solving for P plus Q. Clear? Okay. So geometric mean is going to become 16 square raised to 1 by 2 is 16. Then I have minus half P plus Q minus 2 whole divided by 2 is equal to 1. From here I can say that minus half raised to P plus Q minus 2 divided by 2 is equal to 1 by 16. And now when I equate the powers, I can clearly say that P plus Q minus 2 by 2 should be equal to 4, right? And from here, the value of P plus Q is coming out as 2 into 4, that is 8, plus 2 equal to 10. So this 10 is going to be the final answer for this question. Understood, guys? The question was, I would say, on a moderate level. You have to find roots as well as arithmetic mean, geometric mean. But do not equate the arithmetic mean, equate geometric mean to 1. That will actually simplify the calculation. So P plus Q final value is 10. That will become the answer. Well, the next question is from application of derivatives. The question is saying let normal at all points on a given curve pass through a fixed point a comma b. If the curve passes through again 2 points 3 comma minus 3 and 4 comma minus 2 root 2 and they have mentioned a minus 2 root 2 b is 3, then what is the value of a square plus b square plus ab? Okay, so that means I have to solve for a and b, right? Okay. Now, guys, I'm going to tell you two approaches here. First one is really on a simpler side, but for that you have to think a bit. Do we have a curve such that when we draw normal at all the points, they always passes through one single fixed point? What is that curve? That is a circle. If you can realize this, the question became simple. If you haven't realized this, then also the question is not that much difficult to crack, though it's going to take a bit of time. So if you have realized this part, that a curve can be a circle because all the normals which are drawn at different points on the circle always passes through its center. That means center is nothing but now A comma B. And to get the value of A comma B, what they have said, that this curve is passing through 2 points that are 3 comma minus 3 and 4 comma minus 2 root 2. That means my distance of center from these 2 points should be equal, right? So when I do that, I'll apply the distance formula. A minus 3 whole square plus B plus 3 whole square is equal to A minus 4 whole square plus B plus 2 root 2 whole square. This is going to give me one relation in A and B. So when I expand the entire part, I'm going to get minus 6A plus 6B plus 18 is equal to minus 8A plus 4 root B plus 16 plus 8. When I bring terms to one side, it's going to give me 2A plus 6 times, plus B times of 6 minus 4 root 2 is equal to 16 plus 8 minus 18 is going to give me 6. So that means A minus 2 root 2B plus 3B is equal to 3. And what have they already mentioned in the question? That A minus 2 root 2B is 3. So if I have A minus 2 root 2B is equal to 3, and when I compare these two equations, what I can say clearly that B value will be 0 and A value will come out as 3. So that is going to give me the answer as 9, right? So this was on a simpler side. I can have a curve which is circle whose normals at any points always passes through the center. And we have solved for A and B using the radius formula. Clear? Okay, so this was one approach. But suppose if this doesn't comes in our mind, how should we solve? Well, that part will be a bit tricky. Let's find out what we can do in that case also. So, we have a curve whose normals are given as passing through a fixed point A comma B. So, let's first write the equation of normal. So, we know that slope of tangent will be equal to dy by dx. So, I can say that my slope of normal will be equal to minus 1 by slope of tangent. That is going to give me value that is minus dx by dy, right? So, this, let's say, is the equation of normal. At some variable point x comma y, I have to pass this through the point A comma B. So, when I do that, I can say that it is going to become B minus y is equal to minus 1 by m is going to become dx by dy multiplied by A minus x. And here I'm going to integrate to find a relation between x and y. Or let's say to find equation of curve. So, I'm writing in variable separable form. It's going to become B minus y dy is equal to x minus A dx, and now on integrating both sides, I'm going to get by minus y square by 2 is equal to x square by 2 minus ax plus c. Clear? Now what? Well, now I have got the equation of curve, and what they have said that this curve is passing through these 2 points. So let's substitute these points also. So when I put that, my first point, which is 3 comma minus 3, will give me minus 3b minus 9 by 2 is equal to 9 by 2 minus 3a plus c. That is 3a minus 3b is equal to 9 plus c. Let me take this as 1. And similarly, when I substitute my second point, that is 4 comma minus 2 root 2, it's going to give me minus 2 root 2 times of b minus 8 by 2 is equal to 16 by 2 minus 4a plus c. Further can be written as 4a minus 2 root 2b is equal to 12 plus c. 12 plus c. Clear? Now we are going to subtract these equations. So I'm writing 2 minus 1. So when I do that, I'm going to get A. Then I'll have plus 3 minus 2 root 2 times of B is equal to 3. Right? And now we are going to use the relation which they have mentioned in the question, that A minus 2 root 2B is equal to 3. So in place of 3, if I write here A minus 2 root 2B, on these two parts, when I compare the left and the right hand side part, I can clearly see that B has to be 0. Right? So if my B is 0, I can say that A is equal to 3 by the condition that A minus 2 root 2B is equal to 3. And if my A is equal to 3 and B is 0, again, the value of A square plus B square plus AB will be equal to 9 plus 0 plus 0, that is 9, which will be the final answer. So have you understood? One was a shorter way if we realize that the curve can be a circle with center as A comma B, right? And this one is the next approach. I would definitely put this question on a difficult side. Clear, guys? Have you understood both the approaches? Perfect. So the answer is 9. The next question is from complex numbers. Let's see what the question is saying. Z is a complex number which satisfied the condition. The first condition is modulus of Z plus 5 is less than equal to 4. While the second is Z multiplied by 1 plus iota plus Z bar multiplied by 1 minus iota is greater than equal to minus 10. If the maximum value of mod of Z plus 1 whole square is alpha plus beta root 2, then what is the value of alpha plus beta is what they have asked. So here, what are the curves? Well, the first curve is definitely a circle, but since it's less than equal to, that means my complex number Z will lie on or inside a circle whose center is definitely minus 5 comma 0 and the radius value, the radius for the circle will be 4. So this will be a circle somewhat like this. This point on x-axis will be minus 1 comma 0, right? So all the points inside the circle or on its circumference. This is my first curve. Well, coming on to the second curve, I have somewhat an equation similar to line, but since it's greater than or equal to sign, there will be a region. Now, how can I find this? That this will be equation of line or this will be equation of circle. Whenever you get confused in this, the best part is you can always substitute Z as x plus iota y and actually substitute it and find what the equation is representing. So if you want to go by that, we can say that my first part, that is mod of Z plus 5 less than equal to 4, when I put my Z value as x plus iota y, it's going to become x plus 5 plus iota y whole modulus is less than 4. And you know this part, that modulus of x plus iota y is root over x square plus y square, right? So when I do the squaring, I'm going to get x plus 5 whole square plus y square less than equal to 16. Or you can say minus 16 less than equal to 0. What is this? This is the circle whose center is minus 5 comma 0. Radius is 4 points are lying inside or on its circumference. Clear? Perfect. Okay, so this is my first scenario. What about the second one? I have this equation. Again, when I substitute Z as x plus iota y in this, it's going to become Z, that is x plus iota y multiplied by 1 plus iota. Similarly, what is Z bar? Well, Z bar is nothing but x minus iota y multiplied by 1 minus iota is greater than or equal to minus 10, right? Let's simplify this. So when I simplify this part, it's going to become x plus iota y plus iota x minus y. Then I have x minus iota y minus iota x plus, minus y is greater than or equal to minus 10, right? So what is the region? Well, this iota x and iota y term got cancelled out, and finally I have x minus y plus 5 greater than equal to 0. This line again is passing through center of the circle, that is a point minus 5 comma 0, and it will actually represent what? It will represent all the region which is on same side of origin, right? So I have some points which are below this line and some points which are lying inside the circle. So when I take common, I can say that the region which they will represent will be this one, between P and B on this second half of the circle. Clear? This is my region in which Z is going to lie. Now what? Well, now they have asked what is the maximum value of Z plus 1 whole square. Now tell me guys, what is modulus of Z plus 1 whole square representing? Well, Z plus 1 actually represents distance of complex number Z from this point Q, which is minus 1 comma 0. And its whole square means I have to find distance square maximum value. Now, if I actually see the figure, what can be the maximum possible value of my ZQ distance? Well, that is going to happen when my Z actually moves at which point? My point P, right? This is going to give me the maximum possibility when my complex number Z is farthest from point Q, which is minus 1 comma 0, isn't it? So that means I have to find this distance. This is my modulus of Z plus 1, the maximum value possible. Clear? Now, how can I find this distance? Well, I have Q already with me. I have to just find my point P. How can I find my point P? Well, that can be done very easily. I have my line as x minus y is equal to minus 5. The slope of this line will be 1. That means if I have this angle as theta, my theta value will be pi by 4. Clear? So if I want to write my point P, which is on this line, at a distance of 4 units from my point A, can I use parametric, guys? Yes, I can do that. If I want to write my point P, since it is below A, it's going to be minus 5 minus the distance, that is my radius 4, multiplied by 1 by root 2, comma, minus again 4 multiplied by 1 by root 2. It's cos theta and sin theta values, right? So this is going to come out as minus 5 minus 4 root 2, comma, sorry, minus 5 minus 2 root 2, comma, minus 2 root 2. And now if I want to find my PQ distance, because that is the maximum value, PQ whole square, let me find out. So my PQ whole square will become distance between P and Q, which will be minus 4 minus 2 root 2 whole square plus minus of 2 root 2 whole square. Let's quickly find out what this is coming out as. So when I expand this out, I'll have 16 plus 8 plus 16 root 2 plus 8. So finally it's coming out as 16 plus 16, that is going to become 32. And plus I'll have 16 root 2. So 32 is my alpha and beta is 16. So my final value of alpha plus beta, well, that is going to come out as, I can say that my alpha plus beta value will become 32 plus 16, that is equal to 48. This is going to be the final answer for the question. Clear? Have you understood the region and what was the value of Z for which that distance from minus 1 comma 0 was maximum? Perfect. So the answer for the question is 48. Well, the next question is definitely involving the concept of application of derivatives. This question was a bit tricky. I totally agree with that, but it was not on a difficult level. It was a bit tricky. You have to obviously see the question, observe what the question is telling about, and think of a concept which can be applied in this question. Let's see what the question is saying. Let A be an integer such that all the roots of the polynomial, it's a 5-degree polynomial, 2x raised to 5 plus 5x raised to 4 plus 10x cube plus 10x square plus 10x plus 10. So all the real roots of this polynomial, they lie in the interval a to a plus 1. What is the value of modulus of a? So degree 5 polynomial, obviously when you actually see the polynomial, it's not at all factorizable. That means I directly cannot find its roots and make it lie between a and a plus 1. And it might have all 5 roots lying in a to a plus 1, or 3 roots which are real lying in a to a plus 1, or 1 root which comes out as real lying between a and a plus 1. So if I cannot find the roots of this polynomial, what is another way to solve it if I cannot factorize it? Well, if I take this polynomial as fx, what I'll do is I'll try to find f dash x, which is obviously one more approach which is left with us. If suppose I get f dash x and I somehow get its roots, then I can say that it will have a maxima and a minima, and then I'll try to adjust roots of fx in the range of a and a plus 1. But for that, obviously, I have to solve and find the roots of f dash x if the roots come real. So quickly finding the f dash x value first. This is my polynomial which is given to me. I'm trying to find f dash x. So when I differentiate it, it's going to be 10 times x raised to 4 plus 20 times x cube plus 30 times x square plus 20x plus 10. Taking 10 common, it's going to give me x raised to 4 plus 2x cube plus 3x square plus 2x plus 1. Right? What is this term? Well, this entire 4-degree expression is nothing but square of x square plus x plus 1. Yes, it is actually a perfect square. And you can clearly see that this term cannot be 0. That means it is going to give me the condition that f dash x is greater than 0. Okay, wow. Half part of the question we have already solved. If f dash x is greater than 0, I can say one thing, that fx is an increasing function. That is going to tell me that it is going to have only one real root, right? So if this degree 5 expression has only one real root, that root has to lie between a and a plus 1, right? Perfect. So let's start by getting an idea what this root can be. So if I have my fx, I can clearly say that at 0, the value of f is 10. That means it has to go increasing after this. It cannot be 0 in the positive x-axis part. Then coming on to the negative x-axis part, I'll find the value of function at minus 1. So my f of minus 1 is what? Let's find that value. So it's minus 2 plus 5. Then I have minus 10 plus 10 minus 10 plus 10, which is equal to 3, definitely greater than 0. So at minus 1, it will be positive, right? Perfect. It will go somewhat like this. What about minus 2? Well, I find the minus 2 value when I put x as minus 2 in my degree 5 polynomial. It's going to come out as 2 multiplied by minus 2 raised to 5 plus 5 multiplied by minus 2 raised to 4. Then I have 10 multiplied by minus 2 cube plus 10 multiplied by minus 2 square plus 10 multiplied by minus 2 plus 10. So my f of minus 2 is actually coming out as minus 64. Then it is plus 80. Then it is minus 80. So this part got cancelled out. Then it is plus 40 minus 20 plus 10. Okay, so this value is coming out as minus of 84 plus 50, definitely negative. That means what? That my polynomial fx will be negative for minus 2. Then it is becoming positive for minus 1. Further, it's increasing. And that is going to give me what? That the one root which the polynomial fx has is lying between -2 to -1. That means further I can say that my A value in the question will be -2 such that my A plus 1 becomes -1, right? So my A value is -2 and my modulus of A will be equal to 2. And my modulus of A therefore will be equal to 2. This is the final answer for the question. So have you understood? I personally enjoyed the question. It involved a different concept. The function was not differentiable, so we found f dash x and we found that function has its derivative as greater than 0. That means it's always increasing. And then by hit and trial, we got the idea that -1 value comes out as positive, but -2, when x is -2, my f of -2 value comes out as negative. So my one root, which will be real, will lie between -2 to -1, giving me the A value as -2. Understood? Perfect. So the answer is 2. Well, that was all the paper was about. I hope you have understood the questions. If you have given this shift paper, I hope you have understood what mistakes you have done at that time while attending the paper. And if you have done it on a later date, I hope you must have understood what all mistakes you have done while you were solving the paper at your own place. So guys, if you are preparing for the next shift to come, which is in either March or April or May, I hope you are giving all the 3 shifts. Please make it a point to revise the formulas very thoroughly, as you have already seen many formulas are directly asked or many questions are directly asked based on the formulas. And keep a time limit idea about when you go through the paper, when you attempt the paper, you should not have questions which are left but time has already finished. You should obviously attempt the paper in such a way such that you should go for easy questions first. For difficult, you have time which is left out, because difficult questions require more of your thinking. Sometimes the questions are lengthy, so you require a bit of extra time. So go for easy questions first in all the 3 subjects and then go for lengthier or difficult questions. The main thing is you have to be very thorough in revision and you have to keep a tag of time, right? I hope you have enjoyed the solutions, and for next shift, do not repeat the mistakes which you have done in Feb attempt. All the very best to you guys. Do well.